427 is asking you to find the present value of a perpetuity, that is a cash flow that begins and never ends, of $100 per year if the discount rate is 7%. And then a second part, you're asked, if the rate were to double, what happens to the value of perpetuity? Now I'm going to jump ahead, but it's only so that you bridge this question and the information to what you'll see in later chapters, specifically chapter 7. So the text that you'll find that's posted in this sheet is from chapter 7. You'll see here, made a note, from chapter 7 notes. And what this is talking about here is something that's called the Gordon growth model. And what you learn in chapter 4 is this portion of the Gordon growth model, or this portion of valuing a perpetuity, but really it comes from this larger picture of the Gordon growth model. And what the Gordon growth is showing here in this equation is that you have some present value, and that present value is equal to the dividend paid today times 1 plus a growth rate, whatever the growth is in the dividend, divided by the rate of return minus the growth rate. This will then turn into a statement of, well, the present value is equal to the dividend you receive one period forward, typically 1 year forward, divided by R minus G, where again G is the growth rate. But in the perpetuity that we're looking at, there's zero growth. So really, when growth is 0, or if growth is 0, we have 1 plus 0. 1 plus 0 is 1, and anything times 1 is itself. So it's just simply the dividend in this period. And the discount rate R minus 0 is obviously just R. So this larger equation, or formula for that matter, simplifies down to the present value is equal to the dividend divided by the required rate of return. And this is what you know as the perpetuity formula. What I want you to know is that this formula comes from something more significant, which is the Gordon growth model. Now moving on to solve this question, we're again being asked a perpetuity of $100 per year if the discount rate is 7%. So the perpetuity is this payment here for DO, and we're just dividing it by 0.07. So the present value is equal to 100 divided by 0.07, and we see that that perpetuity should have a value, or it should sell for $1,428.57. So actually, these are rather easy to solve for. In the case when the rate doubles, that is the discount rate grows from 7% to 14%, we want to solve and find out what happens. As you can tell, we're just doubling the 7%. Probably should guess that, well, this value was going to be halved, and that's exactly what's going to happen here. The present value is equal to 100 divided by 0.14, and that that math gives us a value, or present value, of $714.28. We can round up to 29 cents since there's a partial amount there. So really, the value is directly related to the discount rate. So as the discount rate goes up, the present value goes down. And this is a very important thing to understand, especially in an era of rising rates, or when the rates of return are increasing. What should we expect to happen to the value of the assets? That is, they go down. So the larger thing to get from this is when rates go down, asset values go up. That is, there's relative inflation in the price of assets. And when rates go up, prices go down. That is, there is a relative deflation. So a rather interesting aspect to take from this question, again, in terms of larger insights, is how rate affects the price of assets. Again, inversely related. When rates go up, asset prices go down, and when rates go down, asset prices go up. So there's a direct inverse relationship.